Hey everyone, welcome back to the channel Code with AKJ. In today's video, we'll be tackling a fascinating problem, converting a binary tree into double linked list. So the question today is binary tree to DLL. So the question says here, given a binary tree, convert it to a doubly linked list in place. The left and right pointers in nodes will be used as previous and next pointers respectively in converted DLL. The order of nodes in DLL must be the same as the order of given binary tree. The first node of in-order traversal must be the head node of the DLL. Here h is the tree's height and this space is used implicitly for the recursive stack. So given here binary tree, the in-order traversal of this binary tree would be 25, 12, 30 and then 10 and then 36 and 15, and we need to connect these nodes and convert it into a doubly linked list. So given two examples here, 1, 3, 2, the output will be 3, 1, 2 and 2, 1, 3 as well. As it is a doubly linked list, it should be traversed from start to end and from end to start. So our expected time complexity should be O of n number of nodes and O of height of tree in space complexity. This is a classic problem that involves tree traversal and modifying pointers, and we'll explore both a brute force and an optimal solution. So let's dive in. So let's start with the brute force approach. So here I have drawn the binary tree here, and the brute force approach here would be to traverse this binary tree and store all the nodes in our array, and the traversal would be in order traversal, so the values would be 25, 12, 30, 10, 36 and 15. And after converting this into array, iterate through the vector and link the nodes as a doubly linked list. So the task is simple. We have a binary tree where each node has a left and right pointer. We need to convert this binary tree into DLL in place. This means we will be reusing the node points of the tree to form the DLL. So left pointer in each node should act as a previous pointer in the DLL and right pointer as the next pointer. The order of the nodes in the DLL must match the in-order traversal of the binary tree. So initially we'll do the in-order traversal of this binary tree and store it in the array, and we'll iterate over this array and we'll connect these elements using two pointers, previous and next. So in this way we'll tackle this problem using brute force approach and using an extra space array. So here the time complexity would be O of n and space complexity would be O of n. So let's dive into the code and let's try to submit. So this is the code for the brute force approach. Here I have taken the vector of node start to store all the binary tree values. I have called the in-order function to store all the values in vector nodes. The in-order function goes like this. If the root value has null, so we'll return from it and we'll call the left root value, and we'll store the root value inside our vector and we'll give a call to the right subtree. In this way it will store all the elements in our vector in order traversal way. And finally, after storing all the values in our vector nodes, we'll give a call to the solve function where it will connect all these elements from this array into doubly linked list. So here the function goes like this. If node vector is null, we'll return null from here, and initially our head would be the first value of the vector, and we'll also use a previous pointer which will help us connect the elements to its previous node, and we'll iterate over the vector of node array and we'll connect the current nodes left to the previous node, and previous node has a value, then we'll connect the previous nodes right to the current node. And in this way, after maintaining both front and backward pointer, we'll move this previous node to the current node. So after iterating over all the elements from the array, our previous node would point at the last element of the array, and since the last element should have the next value null, so here the previous right should be null. So after connecting all these elements from the array, we'll return the head pointer from here. So let's try to compile and run this. It's working, so let's submit. As you can see, this problem got solved successfully. So here the time complexity would be O of n or O of number of nodes, and space complexity will also be O of n or number of nodes. So let's try to focus on optimizing both this time and space complexity. We need to optimize the space complexity from O of number of nodes to the height of the tree. So, so here we need to ensure that we should not use any external data structure here since we are using vector of node star. So we'll try to avoid this vector of node star in our optimal approach. So instead of using this extra space to store the nodes, we can modify the pointers while doing an in-order traversal here. So we'll maintain a global pointer previous, which keeps track of the last node processed in the DLL. And during the in-order traversal, we directly link these nodes to form the DLL without using any external data structure vector here for storage. So after doing this, we can easily say that the space complexity would be optimized, but still the recursive head would be stored in the form of storage that would be O of height of the tree. So in this way, we can solve this code in our expected space complexity, which is O of height of the tree. So let's try to dry run first and let's move on to the code. So let's try to dry run using this binary tree, and we'll make sure that we will not use any external data structure array here. So we'll do the same in order traversal of this binary tree, and we'll try to use a previous pointer, and while doing the in traversal itself, we'll try to connect these nodes to form a doubly linked list. So we'll give a left call to this element and this left call to this node, and until or unless we find a node which is null. So initially we'll make it as both head and previous, and once we find a root node here, we'll connect this previous to this current node, and we'll make sure that this previous moves from null to the current node 25 here. So in the first step, we'll get a pointer where previous points to this head node, and here head and previous would be at the same node pointing to each other. So from 25 we'll give a right call. Since it is null, we'll return from here, and from this left we'll give return back to its root. So we found another element which is root here. We'll write here 12, and we'll connect previous right to this current node and current nodes left to the previous, and we'll move this prevent to the current node. So in this way, while traversing all the nodes of this binary tree, we'll try to connect these two elements. So again, let's try to dry run few more nodes and we'll move on to the code later. So from 12, we'll give to call to the right node. Here the value is 30. So we'll write here. So the current node is 30, and we'll check whether previous pointer has a value or not. Since it has a value, we'll connect previous right to the current node and current left to the previous node, and we'll move the previous pointer to the current node. So again, from it returns back to the main point, and from 10 we have found and connected all these elements to its left tree, and again we'll get a value 10 here, and we'll connect previous right to the current node, current left to the previous node, and we'll move the previous from 30 to current node 10. In this way, we'll connect all the values using the same process, and finally we'll convert our binary tree into doubly linked list. So let's move on to the code. Here the time complexity would be O of n and space complexity would be O of height of the tree, since we are using recursion here. So the code for the optimal approach is this, where initially the base case would be if root is null, we'll return from it. We'll give a left call, and if we found a null node, we'll point both head and previous to it, and else we'll connect previous right to the root node, which is a current node, and root lefts would be pointing to the previous node, and we'll move previous to the root node. In this way, we'll connect these two elements, and again we'll give a call to the right call. So in this way, while traversing in the binary tree, we'll try to connect those nodes using these two steps. So after connecting all the nodes and converting this binary tree into doubly linked list, we'll return the head pointer of the node. So let's try to compile and run this. So let's submit. As you can see, this problem got solved successfully as well. Here the time complexity is O of number of nodes and space complexity would be O of height of the tree. As we have successfully tackled this problem of converting a binary tree to a doubly linked list. We started with the brute force approach that used one extra space and optimized it by manipulating the pointers in place. So if you found this video helpful, make sure to like, share with your friends and subscribe for more coding solutions. I'll see you in the next video. Thank you.